Let's take a look at this problem. We got negative 12 x to the fifth over 18x. Now the very quick way to do this, if we look at the numbers, of course this is a negative up on top, so that stays up on top. Is a negative divided by positive is negative. If I look at the numbers, I think the largest number divides into both those, which would be 6. 12 divided by 6 is 2. 18 divided by 6 is 3. Now if I were to put a power on this x down here, it'd be x to the first. Whenever you have x to a power over x to a power, you subtract a smaller exponent from the larger one. So 5 minus 1 is 4, and we're going to have x to the fourth power where our larger exponent was, which was on top. And that would be your answer. Now, if we can't see the largest number divides into both of those, you could always do the prime factorization. And let me show that technique now. So I'm going to have negative 12 x to the fifth over 18x. Well, if we look at 12, I'll create my tree. We'll start with our first prime, which is 2. And 2 does go into 12. 2 times 6. 2's primes, we circle it. We're still on 2, and this is divisible by 2, so it's 2 times 3. So this top part, I'm going to have a negative, and then 2 times 2 times 3, and I'll still leave it as 5x's there, like that. I won't write it out, because that could be x to the 50th, so you don't want to do it right out 50x's. Now for 18. If I do the prime factorization of that, that's 2 times 9, and 9 is 3 times 3. So this will be 2 times 3 times 3 times an x. Okay, number-wise, this has a 2, this has a 2, so those 2's cancel. This one has a 3, this one has a 3, so those 3's going to cancel. Okay, so negative stays up on top. We got a 2. And down below we have a 3 left. Okay, now let's handle x's. Again, same idea as what we did in the first attempt. If you have x, that's like x to the first. Subtract the smaller exponent from the larger one. 5 minus 1 is 4, so we'll have x to the fourth where our larger exponent was, which was on top. And that gives us our answer.